Hey guys, welcome back to the shop. Today I'm going to be on the Milltronics CNC lathe knocking out a repeat job. Only the customer, which is the welding shop, have changed the material that we're going to be machining these out of. So I've already shown this before, and this is the part that I showed in a previous video right here. These are made out of, machined out of 6061 aluminum, and they're called a standoff. And these are designed to be welded directly onto a machine, and you have some kind of either a pneumatic or hydraulic arm that comes and bolts to the end of that. My understanding, this goes to the airport, the local airport, and it has to do with a luggage machine out there. And I don't know the specifics of it, but I know that this arm connects here, and this machine is basically like raised and lowered all the time. These keep breaking off, and so the welding shop, you know, they call Joe and they say, we broke one of those standoffs, can you come out and weld another one on? They've done this several times, and the problem is that where this is located in the machine, it's very hard to get to. He says that you have to stretch your leads way out because you can't get the truck in there where it's at, so you have to run your leads way through this building and get way up in this machine and then repair it. So they have to grind the weld off, weld another one on, only to discover that it breaks again a little ways down the road. So what they've done is they've tried to do a redesign on this to make it work better, maybe last longer. So we're gonna find out. They wanted to go to a steel version instead of this aluminum. I've already got a few of these machined, but I'll tell you where I'm at on these. So we've got a few of these machined in steel. It's the same thing, only we don't have a weld bevel machined on that side right there. Because what they're doing is they're cutting out some steel plates that these will get slipped into. They'll have a nice big weld bead around that. So these will have a plate welded to it like that. That plate's gonna have a hole pattern drilled in it or burned in it. I believe they're gonna cut it down the plasma. And what they're gonna do is where the aluminum ones are were always welded on, they're gonna drill and tap that machine so they can take the steel version that's welded to a plate and just bolt it on there. So if the steel one breaks off, they can simply, hopefully this will work the way they're wanting to, they can unbolt the plate that has the broken standoff, take another one that's already made up on the shelf, bolt it on. It's a much easier, faster, simpler repair of the job without having to run welding leads through there to weld these back onto the machine. It sounds to me like maybe the machine itself has a flaw in the design, but I don't know anything about it. I'm just asked if I could machine these, so that's what we're gonna do. So I have modified my Fusion 360 program that we made to machine the aluminum ones. Made a few changes to our feeds and speeds to make the steel. But the other thing that we're gonna be doing this time is I'm gonna be trying rigid tapping on the CNC lathe for the first time machining these. Now I've got 4 of these made right here, because I wanted to go ahead and test the program, make sure everything was good, get our diameters on size, make sure that our holes are correct and things like that. And then I just used the flex arm to power tap these guys right here. Quick and easy. So I have ordered a couple of the Technics brand collet chucks. This is the ER25 collet chucks. This is something that I finally realized that they made. You know, Technics has these on their website. This is made for the 1¼ bar holders that go on my CNC lathe. And then an ER25 collet goes in there. So I got a couple of these. I've already got one installed, and we're gonna go ahead and get another one installed here. I have a 5/16 tap collet right here. This is a Technics. I ordered a set of these, so I've got them from 1/4 inch up to 1/2 inch in an actual tap collet. We have some new Cleveland taps right here. So this is a new 5/16 spiral flute tap from Technics. We have our tap collet made to hold a 5/16 tap, and we'll install that in the collet right there. So excited about these guys right here. I think this is going to be better than the other collet chucks that I have on there already, but having these 2 on there are going to give me the ability to have 4 round shank tools on the CNC lathe. So I'm pretty excited about that, because I needed to add a spot drill And then we have 2 different drill sizes, and then I wanted to be able to go back in with the tap. So I needed to have 4 holders there, so that's what we're gonna do. The Technics, there's the part number that the collet chuck is. And they actually wanted to go ahead and create a promo code for all the A-Bomb viewers out there. If you go to their web store and make an order and use the promo code BOOTH20, they'll give you 20% off an order, all right? So keep that in mind. I'll have the description. I'll have the links and the code down in the description below. So let's go on over to the Milltronics. I want to get this guy installed, get our tap installed, and I'm excited to try my first rigid tapping on the CNC lathe. Hopefully we'll have some success. Okay, I'm over here on the CNC lathe. I've already got the first collet chuck installed right here. These are the 2 that I previously had installed, and I am liking these Technics ER25 that fit the pocket so much that I've gone ahead and ordered 2 more of these, and I'm going to remove these and just save them for if I need another pocket with a round shank tool, because I do have another one of these blocks. But that way I have 4 of these collet chucks that are all kind of equal on the stick out right here. So we're going to get ready to install that one there. I've already indicated the tool block right here using our coaxial indicator. And something that I picked up on this job, and big thanks to Steve Sherman over there at Milltronics. He kind of gave me this tip. I didn't think about this before. Once you get one of these pockets indicated in X, these other ones should be in the same position because you're on the same rotational center line right there. So I've been indicating each one of these individually and then do an X tool to mark the X0 location. So that's something that I just realized. I should have realized this a while back, but I just didn't think about it. So that's pretty simple to do. Over here on the controller, I'm going to go ahead and go back into auto mode. And if we go to our perimeters in the tool table, we have our X length right there, which is 10.275. And so we're using 3, 4, 5, and 6 on our tool turret. I've got these indicated, so they're really close, just using the coaxial indicator. 10.275, and then the last one, 10.274. So it's about 1 thou off from the other previous tools. That's the one that we're doing right here, tool number 3. It's about 1 thousandths off. So anyway, what I was getting at was what I learned here, because this is stuff that I'm learning obviously, is that once you have one of these indicated and you have your X position, your X length, then you can go to the other tool and enter the same exact value that you already indicated for the previous pocket and then make them all the same. So very simple, basic, I know, and I'm glad that I finally picked up on that because I should have learned that a long time ago. So I don't have to do this every time I want to put a new tool in. But this was the first time that we stuck this tool block over on this number 3. So I was adding one that we haven't ever indicated before. So anyway, just a nice little trick that I finally picked up here on the CNC. Always learning, but I'm really enjoying it though. All right, so this tool right here, this is our new Technics collet chuck, and I have a 1/2 inch diameter spotting drill installed into that one. So these are some spotting drills that I just picked up from Cleveland. This is the one that I have installed right there, and I needed a little spotting drill like this so that I could come in here and spot our workpiece and then come in here with the following drills. And I didn't know which one I wanted, so I got these guys too. These are considered the shorts. They don't have any side relief on them at all. They're just, you know, ground to the diameter, but these work great for spot drills as well, just a little bit longer. So I'm gonna go with this one right here, and it's been working well on my first 4 work pieces that we already did. So anyway, I was gonna point that out. And so this one that we're getting ready to install right here is going to be our 5/16 tap. I've got the collet chuck installed. I'm just verifying that I do have this in the center. So that needle's wiggling less than 1/2 thousandths on rotation right there. So I know that one's pretty good. This is a different manufacturer tool block than the previous ones here. So maybe it's, you know, 1 thousandths different on the center line. I don't think 1 thousandths on the rotational center line is really going to make a big deal on, especially on drills. So I'm just going to leave it indicated where it's at. But if I add another one of these later on, now I know I don't have to do this. I can just look at the value of one of these in X and just make it the exact same. All right, we got our new Cleveland tap installed. I'm going to use my Heimer Torque Master to get it torqued in properly. You have a line on this dial indicator here indicating what size collet you're tightening, and you just line it up on it. Trying to be sure that I don't slip off and split my hand wide open. That should be right. ER25. Give it another pull, make sure. Yep, I'm there. I wanted to give you a rundown of what our program is going to look like here. So this is the modified version of the standoff made into steel. And I do have a cool section analysis here that we can turn on. It kind of splits it and you can see the inside of it. So this is going to be our 3/8 diameter. This is our 5/16 drilled and tapped bore right here. And then you have on the outside, which we're going to turn first. We go back to this analysis and turn that off. So we have a 3/4 inch journal right here, which finishes at 0.745. And then the OD, which is not critical. We're starting with 1¼ inch cold rolled material. I don't know if I mentioned that. We're turning 1018 cold rolled. All we're doing on the outside is taking a 10 thou cut on there just to clean it up and make it look pretty. That's all we're doing. So the diameter on that doesn't matter. It's going to be a plasma cut hole that's dropped into, and then it's a fillet welt all the way around it. All right, so if we go back to our analysis there, we got it split. I'm going to just do a simulation so you can see what it's going to look like here. Play our simulation. So we'll make a face cut. All right, and then we're going to rough off the OD there. And once it's roughed off, it's going to come back and make a finish pass all the way down it, clean it up. And then we'll come in with a spot drill, 3/8 drill, then our letter F tap size for 5/16. And notice, let me come back right here. This area right here, what I have done is I've taken our letter F drill and I've taken it to an additional negative 250 thousandths. I'm sorry, 125 thousandths, so 1/8 of an inch right here. I just wanted to point that out. So we gave that a little extra depth so that when we come in with our tap, this is going to be our tap right here. And I have it set to a positive 0.125 so that this should give me a 1/4 inch of leeway right here between the bottom of the hole and the bottom of the tap. So this is obviously my biggest worry right here, is bringing the tap in and then bottoming out and snapping it off, or breaking it off otherwise. You know, I'm just really concerned about this. So you guys are going to see my first rigid tapping on the CNC lathe with this job right here. All right, so anyway, we'll finish this out. Tap comes out, and then I did want to show you this. Let me back up and show you what we're doing right here. I'm going to bring this back around to the top, and let's come in. So this is our parting. I've got my tongue alloy parting tool. It's going to come in. I'm going to slow this down, and what you're going to see it do right here, I'd like to chamfer the back side. So by the way, thanks to Kevin at Mechanical Advantage for going over this with me. I told you we train every week, and he goes over these programs and looks at them and helps me. And he made a suggestion on breaking this corner here. So if you come in with our tool, let me see if I can do it this way. Tool's going to come in. It's going to go down to that depth right there to give us a little bit of relief in this corner. All right, and then it's going to come up. I went the wrong way. Where you at? There we go. All right, so it's going to come in at a 45-degree angle, and it's going to break a 15 thou chamfer on that back side, just like so. And then it's going to continue on with the parting and part the piece off, like so. All right, and then that'll be the end of the program right there. So that should be a finished part. The only thing I'm going to have left at the end is right here where the parting tool parts it off. There's going to be a little nub right there that I'm just going to take to the manual lathe and just face that little bit off. It only takes, 30 seconds to do that. Otherwise, we should have a completely finished part once we're finished. So let's go to the lathe and see if we can make this happen. I'm ready to give this a go. I wanted to point out, so when I do my stock here, I just pull it out to 3 1/4 on the rule, and then the first pass will be a face cut, and it'll clean up about 10 thousandths off of that. So rough it, finish turn it, and then we'll go to our drill cycles. And I haven't tapped yet, so this is going to be the first run. I've already Z'd it, Z0 on the face after we faced it off there. Everything should be good. So if it breaks, it breaks. Let's just hit cycle start and see what happens, all right? I'm gonna run the turning dry just so that it doesn't throw coolant everywhere, but I am gonna turn it on for the finish and for the drills as well. These roughing passes look beautiful on this 1018. I will say that the finish pass doesn't do as well because we're only taking 10 thousandths, so it's going to try to string on us. And what I'll do is I'll just stop the spindle and remove the bird's nest if it's on there. All right, we're going to engage coolant. Clean it up 10 thou off that OD, and you see the stringy chips there hanging on the tool. So what I do here, I have an optional stop, and I just stop the spindle, come in here and just knock that off, and then I'll start spindle and hit cycle start. Let me make sure the camera is cleaned off. Actually, let me clean this off real quick. Okay, spindle clockwise, cycle start. So first drill is going to be a spot drill. Second one's going to be our 3/8 drill. I have a breaking chip cycle on this just to break the stringy chips. All right, letter F drill, tap size for 5/16. I've got those coolant nozzles adjusted as closely as I can to try to get the most coolant I can in those drills and on the tap as well. All right, moment of truth. Let's go for it. Yep, it didn't like it. It did not like it. Oh man. All right, you saw it. You saw it for the first time. We snapped the tap. So I don't know what happened there. I'm gonna have to go back and revisit it. Could have, I don't know. It shouldn't have bottomed out, but that's okay. Let's go ahead and we'll finish this out. We're gonna part it off now. A little undercut, and then it's gonna bevel it and finish parting it all the way off. All right, there we go. Wait for the chuck to stop. And then I've got a board down here that I'm using to just catch them softly. So, man, I was really hoping I was gonna pull one through on that, but I don't know. I need to go back in our program and just make sure that we're running on the correct pitch for 18 threads per inch. And we saw it in the graphics. It should not have went all the way down to the bottom of that hole. I don't know if it you know, the chips just bound up because we weren't getting coolant in there, but it really makes me nervous because it's such a deep hole. We may just go ahead and eliminate this tapping on the rest of these and just go back to our flex arm and finish tapping the rest of them. I don't want to break another new tap. I mean, that was a brand spanking new tap there, and I can't keep doing that. So we may just have to revisit our rigid tapping with a separate test piece and make sure that everything is functioning like it's supposed to and not on an actual workpiece. That's a bummer, but we're going to go ahead and get the rest of these finished. I'm going to eliminate the tapping cycle so that I can come back to that later. All right, I had an idea. Before I continue on, I want to come over here to the manual lathe. I'm going to go ahead and I'm just going to sacrifice this part right here because I got plenty of material to make another one. I want to go ahead and face the back side of this off so that we can access the tap hole and see if we can tell if that tap is all the way in the bottom, if it bottomed out, or if there's a gap down there like it should. There should be a gap in the bottom. That's what I want to see, is if it's there, because I'm wondering maybe it just didn't have any coolant getting down into the hole, because it is a very deep hole. It goes about 1 7/8 deep, and it could be just lack of lubrication that caused that tap to snap off. Finally getting there, see it there, but I got to pull it out some. I can't go in there much deeper. That was 400 thousandths there. All right, I think we can I think we should be able to see that. Okay, here's a close look at the one that we broke the tap off, and you can see that the tap did not bottom itself out into the bottom of the hole there. So it was still cutting whenever it broke off. So I'm gonna make the assumption, I haven't checked the program yet, so either the lead is off from the tap, or it just did not get enough coolant, lubrication down in there, galled it up and broke it off. So you can see how deep it is. Like I said, that hole goes 1 7/8 deep all the way through there. It's a pretty deep hole. So I think for the rest of these, since I've got to make 10 of these. All right, so we've got 4 of these here. I'm going to go ahead and just make 6 more. And instead of risk breaking another tap off, because we're learning what's going on here, we'll just go to our flex arm and power tap them. That's what I did with these guys, and it worked just fine. So that is a total bummer. I was really excited to see this happen for the first time, but unfortunately just can't get everything right the first time every time. It only works right part of the time, correct? I don't know, did I say that right? Anyway, this one was a failure, but let's go ahead and get the rest of these guys finished. All right, let's finish these guys. So this is my little order of operation. I only got a few of these guys, so this is the way we're doing it. Scale this out to 3 1/4. Okay, let's make one without the optional stop and see how long it takes. I turned optional stop back on because that bird's nest right there. I'll turn it back off after we finish this. I just want to be able to get in there and safely be able to remove these chips like that, get them out of the way. This one came way over here. All right. I'm going to turn our optional stop back off and continue. By the way, I forgot to mention, I have the spot drill set so that it actually leaves a chamfer on that 3/8 diameter hole there. Another trick that I'm finally picking up on and learning how to do. So I just skipped the tapping cycle. That's that new tongue alloy parting tool. I've really been enjoying that thing. It does a great job. Okay, so run time was 2 minutes and 50 seconds. And everything is looking good. You can see our chamfer on there looks pretty good. The finish looks pretty good. All we got to do is just machine that little nub off there. I mean, you could technically just hit it with a grinder if you wanted to, but I like to face it. And then we go to the flex arm and just power tap the 5/16 hole. All right, so we'll just use our flex arm here to go ahead and tap the remaining standoffs that we machined. I already went to the manual lathe and faced that little tip off the back of it right there, so that's already done. And I've got a little stop so we can just take our workpiece and just drop it down in the chuck there and snug it up. And by the way, I am using the what Flex is calling the Stars and Stripes flex arm. This is part of a giveaway that I was helping them with, but by the time you guys see this video, the giveaway is already going to be ended, so I'm not going talk about the giveaway about this guy. But after this job right here, I'm actually going to be putting this back in the box it came with and sending it back up there to Flex Machine Tools because somebody is about to win this guy. Works really good. The A32 model, I believe this goes up to 9/16. Forgive me if I had said that wrong. You can at least do a 1/2 inch with it, I know, but it works pretty good. Pneumatic, and got a little pneumatic motor here. So we're going to use our anchor lube for our tapping fluid today. Just give it a dunk. And my plan is to just power tap it all the way down until it bottoms, and then the clutch should work at that point, keep it from breaking the tap. So here we go. I was anticipating the clutch working, but I think I hit it right at the moment that it came down to the bottom, so you didn't really hear the clutch on that one. But you can see it worked good. And the anchor lube works really well for stuff like this too. All right, well, this job is finished up. We have all of our steel standoffs ready to go, all on size, tapped, and they're ready to go over to the welding shop. He's already wondering when he was going to get these, so I wanted to get them finished up today because he wants to go ahead and get these guys welded and have all of these on the shelf ready to go at a moment's notice. So I do have a couple extra right here. So, you know, every time I set up the CNC lathe or mill and do some projects, I usually try to get everything, you know, get my program rolling correctly, and I make little tweaks here and there, feeds and speeds, and this represents that, not having like good finishes on these. But I usually have an extra part. I have a little table in the office in there. When I make parts like this, I usually make an extra one for myself, just as a reminder of things that I made here in this shop on the CNC. Also as a sample in case somebody comes back and wants to make more. I have a sample here I can look at, you know, and reference to. And of course we have our broken tap standoff right here. This is another reminder of, you know, a failure that I had learning how to do CNC work. Not a big deal. I was kind of half expecting this to happen, but then again, the CNC machine is supposed to do what you tell it to do, and we told it to tap for a 5/16 18. I was talking to my buddy Kevin over at mechanicaladvantage.com. He's got another customer of his, another client that he works with that does a lot of CNC lathe work, and they had told him that they were experiencing the same problems like I had today with tap breaking on the CNC work. So they went to a floating tap holder, and so that may be something I look into doing. You know, we just recently added the micro float to the Flex CNC, so I'm going to look in to see if Technics actually has one of those floating holders that goes in the CNC lathe there as well. And they had claimed that solved their problems, that they were actually having issues with the tap breaking when it reversed direction. and the holder that they had showed, it looked like it had 1.25 inch shank, and it looked like it had quite a bit of movement there to it, you know, maybe like 1/4 inch of float in and out. So that's going to be something that I look into and see if maybe we just need to add that to our Milltronics lathe for these rigid tappings. But it's definitely something that I'm going to continue to work on and try to figure out how to make this right, because we should be able to do rigid tapping in the lathe. That's one of the processes that it should be able to handle. But anyway, this job is finished up, and I hope you had fun watching the video, and I hope to see you here again on the next project. All right, see you guys later.